Then the president will come up to give her welcome remarks. Then the president after that will come up to introduce the chairman for today. The chairman will then introduce the speaker, and then afterwards we will have a presentation. The presentation will be followed by panel discussion. So the president-elect will first introduce the panelists, and they will give their views, and then summarize the presentation. The chairman will then summarize the presentation. This will then be followed by Q&A session that will be moderated by the chairman and myself. Then we will have closing remarks from our sponsor, BOCA Energy Resources Limited. We will then present gift. The president will present a gift from NAPE to the sponsors. I'll come up then with the announcements for NAPE. We'll celebrate any our fellows that are over 80 years with us today. We will celebrate them, and then vote of thanks will be followed through by the president-elect, and then we will go for lunch. Thank you so much. I'll call on the president-elect now to welcome our dignitaries with us. Thank you.
Thank you very much, PS. Thank you once again. I want to use this opportunity to welcome everybody here. We have a couple of our fellows here, as well as our members. I can see the president of NAPE, Mrs. Olajumoke Ajayi, she's here. FNAPE, we have a couple of other NAPE fellows here, like we have Mr. Chamberlain Oyubo. Welcome, sir. We have a former president, a past president, in the name of Mr. Alex Taka. You're welcome, sir. We also have the chairman of this occasion, which is also a fellow, Mr. Mascot Ogunjomiwo. We also have Mr. Isaac Odedera. These are all fellows of NAPE. They are all here. We have Mr. KK Kanu. He's also here, sir. I welcome you, sir. We have also Mr. Kazim Kolosho. He's also here. I can cite him. I don't know. Mr. Kazim. Okay, he's coming back. I know I saw him. And then we have Mr. Tony Akinosho, FNAPE. Welcome, sir. So without wasting our time, we will start. However, we would like to call on the NAPE president, Madam Olajumoke Ajayi, to please give us her welcome remarks before we introduce the chairman. Thank you. Also, as we have our fellows come in, we'll announce them. Thank you.
Thank you, my PE. Good morning, everyone, both those who are here physically and those who have joined us online. Thank you for making time every month to be here. And especially I want to thank our sponsors of today. And I'm delighted that you're making this presentation on this topic, from swamp to deep water, designing fit-for-purpose site surveys across Nigeria's offshore blocks. This type of survey is very, very important because it helps to de-risk our assets and also help to ensure that we know what we are doing before we take any rig to the location to drill. It's not cheap to drill, and it's always better to do proper planning, and survey is very important. Like we all know, marginal fields today, many people are offshore, many people have marginal field offshore and all that, and limited funds. So it's always better to have this type of information well ahead. And I believe that BOCA will also be looking at the possibility of having multi-client data that, small players can go to purchase data ahead of their activities. But we'll wait to hear from you to know what you have. I don't know if it's something you've already done or you've always done, or is a thing you are looking at. But it's a good one that I believe everybody will learn from, because geotechnical and geohazard surveys for rig positioning, pipeline laying, drilling are very, very important. So thank you very much for sponsoring today's event and coming up with this very important topic. And I can see that you are well prepared to give us this talk today, because the two panelists are from BOCA and also the speaker. So we have 3 competent people coming to speak to us. So again, thank you very much. And to everyone present here, I want us all to listen attentively. You may be operating onshore, but you don't know what you have in store for yourself or your company. You may, the topic of today could even give you that appetite to go offshore or deep water. So I won't want to say too much, but all I want to say is that let's listen attentively and gather as much knowledge as we can and ask questions that will enable us plan well, because we are explorers, and our ideas will continue to find oil and gas. Thank you very much, everyone.
Yeah, thank you, Madam President, for that beautiful remark. We have other fellows online. We have Mr. Sukumi Iola, he's online. We have Dr. Olajide Ulufuyi, he's also online. We have Dr. Abimbola Drubiton, he's also online. Something in NAPE is that once you don't make it right, somebody will always walk up to you to what? To correct you on that. So at this point, I want to correct myself and say that we have in our midst the second president of NAPE. After NAPE was bettered, we had somebody who was the first president. The second president is with us here, and I didn't introduce him properly, and I'm doing that. We have Mr. Chamberlain Oyubo. Please, let's give him a round of applause. Thank you, sir. Thank you, sir, for coming. So I think at this time, at this juncture, I would like to call on the speaker. Chris, can you come up? I also want to call up the chairman. Can you come up? That is Mr. Mascot. Also to call on James, one of the panelists. Please come up. And then Mr. Reginald. While I want them to come up, is that after introducing them and all that, by the time the speaker starts his presentation, they will all go down and then listen to the topic and then come back again. But it's just for us to see those that we have as chairman, speaker, and then panelists. Thank you very much. So, without wasting time, I want to introduce the chairman for today. The chairman is Mr. Esan Mascot Ogujomiwo. He's a fellow of NAPE. That's him here. Mascot is a Nigerian oil and gas professional, energy industry analyst, and financial markets enthusiast with extensive experience spanning the petroleum sector, oil field services, and investment markets. His career reflects a unique blend of technical industry knowledge, strategic business engagement, and economic insights, particularly within Nigeria's evolving energy landscape. Mascot currently serves as an oil field service account manager at SLB, formerly Schlumberger, one of the world's leading energy technology companies. In his role, he manages the key client relationships and supports operational coordination across upstream oil and gas projects. He has worked with NNPC in technical and managerial roles. He also had a stint with Halliburton and the United Geophysical Limited. Beyond his corporate role, Mascot has demonstrated strong commitment to professional development within the petroleum industry. He previously served as Treasurer and Financial Secretary of NAPE, one of Africa's most influential professional bodies for geoscientists and energy professionals. Mascot is also associated with Prairie Energy Limited, reflecting his entrepreneurial interests in advancing energy solutions and supporting the growth of indigenous participation in Nigeria's energy value chain. In addition to his professional responsibilities, he's an active voice in conversations about Nigeria's energy economics and the intersection of the energy sector with the broader economy. Through industry forum and policy discussions, he provides insights on the challenges and opportunities facing Nigeria's petroleum industry. With experience bridging energy operations, professional leadership, and financial market awareness, Mr. Mascot brings a balance and an informed perspective to discussions on energy policy, petroleum industry development, and economic transformation in Africa. Ladies and gentlemen, please permit me to present to you the chairman for this occasion, which is Mr. Mascot. Mascot, please, you will introduce the speaker and then go ahead.
Yeah, thank you, P. Thank you. The President and our distinguished fellows of NAPE and ladies and gentlemen here present, it's an honor and privilege to be sharing this session. Thank you very much for the opportunity. So I want to introduce the speaker because this is a topic an area where a lot of us geoscientists don't pick it interesting, but I'm happy we now have geoscientists that are picking interest in this company, because through my career in NNPC, the people doing this job, which is the basic geoscience skills, are surveyors and vessel owners. So they just now hire geoscientists to support the technical roles in their operation. So now we have the core scientists now taking up the role. So BOCA is, thank you for that. Kudos to you. We love to see more of that in the industry. So Chris Alger is a renowned geoscientist. He has spent all his career in investigation, geophysical and geotechnical investigation, with over 25 years experience in the North Sea, UK, and now he's collaborating with BOCA in Nigeria to do geophysical works, geophysical and geotechnical work. So he has wide experience, far beyond oil and gas. He also do a lot of work for renewable, when they are trying to build renewable facility like wind farm. So Chris has been a figure to reckon with in the profession. He has worked extensively with peak processing focus on geophysical and geotechnical investigation. So, and his work all around the world in Australia, Middle East, and North America. So I welcome Chris. So he's going to give a great insight into what the geophysical and geotechnical is all about. So you are welcome as we listen to Chris. Thank you.
Okay, so you can go down. So while Chris does his presentation, when he's done, then we can also come up again. Thank you. So Chris, go ahead.
Thank you very much, Chairman, for introducing me there, and good morning, ladies and gentlemen. It's a pleasure to be here, and hopefully you'll enjoy my talk. Just to give a little bit of context about who I am and what I do, I've worked in site investigation for about 25 years now. All facets all around the world, so we do oil and gas work. In Europe, currently we're doing a lot of wind farm developments. They've become very popular. Pipeline inspection, pipeline prelay surveys, cable surveys. So it covers a wide band of topics. One of the good things about that has always been that when there's a quiet period in oil and gas, you usually find that cables or wind is very popular. What we're experiencing at the moment is a very quiet time in wind and renewables, and oil and gas has suddenly become very relevant again. So I think that's a good thing. I've also written this presentation with the help of a consultant, a UK-based consultant called Karen Ware. So my skills are in the survey work and the design and planning, and hers are in advising on minimising drilling risk. So there are bits of this where having her here would have been useful, but unfortunately she couldn't make it. But I'll try my best to present. So, the first slide. A properly conducted drilling hazard site survey for an offshore drilling location is essential to minimise the risk of harm to personnel, equipment, and to protect the natural environment. And that's from the International Association of Oil and Gas Producers. So why site surveys are critical, and the most critical point always is that first one. Protects people, assets, and the environment. It's no good doing all of the other bits successfully if you fail on that first point. That's always key. Safety, that's the most important part. But the actual bits, once we get into the field, we're looking to confirm water depths. This could be regional bathymetry to advise on how we can safely bring rigs into the area. You're working a lot of variable water depths in Nigeria, whereas my upbringing in the UK, it's all pretty consistent, as I'll sort of elaborate on early. The water depths don't change that much. So we want to confirm water depths accurately. That will also help when we come to laying pipelines and so forth, because slopes can cause pipeline issues. You don't flow so well upslope, so that's another key. We want to understand the seabed conditions. What are the soils? What are the soils in the upper section? How will this affect rig installation, pipeline installation, and so forth? Locate obstructions and existing infrastructure. There might be assets that have been laid on the seafloor for 30, 40 years that people don't know the accurate position of. It happens. I've got slides later on from some parts of the world that will show you where someone has damaged one of their assets because they didn't know where it was. Assess the subsurface geology. That helps in designing what type of rig to use, how we're going to drill, and so forth. There'll also be trenching, pipelines, cables. And finally, identify the geohazards. So everyone thinks shallow gas, because that can be a big problem. But there are others there. Water flows, hydrates, faulting, channeling. Channeling's a big one for the UK. There are channels here, but we spend a lot of time looking at channels. And the core principle of what we're doing is balancing the cost of a survey against the risk. Now, we want to reduce the risk when it comes to drilling as much as possible. But a survey that doesn't reduce the risk and costs money is a wasted opportunity, because we haven't invested there. We've missed the point. So we'll talk more about that as we go on. And there are some slides of some issues. I think they're from various parts around the world. I think this is an Australian punch through, a Norwegian blowout. I'm led to believe by Karen that that was West Nile Delta, where they managed to wrap a cable around a drill bit. And this is a local one from OML 86 that I was involved in last year. Ooh. So, Nigeria has some brilliant diversity in its offshore environment. A wide range of water depths, things that I just don't see in other parts of the world. So we're working from swamps to sort of standard jack-up water depths, so 80 to 100 meters, and then into sort of semi-sub-deep water territory. So we see a really wide range of environments. That leads to highly variable conditions. No two sites are the same. Often within a block, you'll see very variable conditions, meaning everything is unique. And you can't always use exactly the same theory for each site survey. There'll be operational and logistical challenges. I'm not that experienced in swamp work, but there's a challenge there I can see straight away that you perhaps don't get with a jack-up. And constraints of equipment. The world over, there's never enough geotechnical borehole vessels at the time when everyone wants a geotechnical borehole. That's just always been the way, and you end up with a geophysical survey being carried out and then the geotechnical work being done a long time after. But better planning can sometimes mitigate that. And the key point, survey design must be environmentally specific, risk-driven, and development-focused. You can, with good planning, acquire data that will cover a lot of points that you'll need further down the line. So it might be for drilling a well at that point, but later on it might help with pipeline installation and so forth. So the better data you acquire at the start, the better your long time will be. And this just follows on from that with survey design is everything. We've talked about variable conditions, even across a single block, accounting for the water depth, the geology, and the shallow gas as different risks and how that drives how we design the survey. And the survey design must adapt to local conditions. Point here being, if it's poorly designed, it might not reduce risk, and then it's just expensive. And the data that doesn't answer that critical question is a missed opportunity. Oh, sorry. So, a map of the water depths offshore Nigeria, from nothing to 5,000 meters or 4,000 meters. And site survey work is being carried out across all this, particularly with marginal fields coming up that aren't necessarily going to be in the easiest areas that have been previously utilised. But to give an idea of how this varies from the UK, if I was to draw the standard for probably 95% of our offshore wells, they're between 30 metres and 150 metres. You've got so much more diversity, which brings so many more challenges, but also really interesting data. No, am I? Oh. Right. There we go. Thank you. So the first environment, swamps near shore. Number of issues: the soils, the variability, the potential for shallow gas, faulting, accessing the area. They're not always easy to reach. They could be environmentally sensitive. No one wants to be able to see a drill rig from their house. That's always tricky. And the development scenarios have actually, once you've drilled and then extracting and putting infrastructure in place, is a real challenge. This is a shallow water example showing some of the challenges here. So there is our data. This is 2D high-resolution seismic data. Within this line, we only gain one area where we can actually see any data because we've got shallow gas masking the rest of the area. We can't make any firm conclusions about what's going on there. It's an unknown. And so in this case, you couldn't recommend to drill there. There are too many unknowns. And if you're going to acquire a survey in an area like that, is there any reason to acquire the survey? You'd be better off mitigating your risks during drilling rather than wasting money on the survey. We then move into sort of more traditional water depths. We're talking sort of shallow water, jack-up rigs. We're really interested by the soils again for jack-up stability. The access, we talked about the bathymetry being key to bringing rigs into areas. We need to know where that water bottom is. We also might be compromised by existing infrastructure that restricts what we can do. No one wants to take a streamer and collide with an existing platform because that causes problems to everyone. The data again, gas, faulting, can be very challenging to actually acquire good seismic data in sort of 3 to 5, 10 meters water depth with traditional offshore techniques because you need a little bit of offset between streamer and source, and it's very difficult to get that in these conditions. So these are tricky. Now we move a little bit further downslope. We've got kind of what I'd call ideal water depths for site survey acquisition. These are depths where you've got enough water to acquire good multi-beam data. The seismic works really well because you can get a little bit of offset between your source and streamer, and you can generally collect nice data sets, but there'll still be issues. We're still looking at the sediments for potential punch-through. There'll still be shallow gas and faults. And you get on that borderline of, do we use a jack-up or do we need a semi-sub at about 100 meters? And so there'll be mixed development scenarios, potential for either option here. And when designing a survey, we have to work out what density of lines we require, how much data we require. If we're doing a jack-up, we're going to need a tight density of lines at the proposed location, but less lines are needed further away from that location because that's where we're going to situate our rig, and that's where we want to also acquire our geotechnical data, and we want to integrate the two, so density is key. If we're going to use a semi-sub, we need to acquire over a wider area to allow for the anchor pattern, and depending on the water depth, the anchor pattern could stretch for thousands of meters. So there are decisions that need to be made there that will influence everything further on. And finally, deep water. So we've got steep slopes, complex seabed morphology, and slope variability. So we'll be working in a compressional zone, upslope, extensional on the lower slopes. We'll have mass transport deposits where we've had slope failure and sediments have slipped down slope. Shallow hazards, again, same as we've talked about previously, and then the potential for gas hydrates where conditions are correct. Some of the problems we typically see in these environments are the risk of losses, hull collapse and side tracks when drilling. And those are driven by the soils and the sediment loading. Locally, conditions can vary a lot, just a little bit downslope or even working across the slope. So each site is its own, it's individual. The faults, again, we try and avoid in the upsection if we can, but not always possible. And shallow gas, again, we can identify it nice and easily. We can avoid it. Sometimes that's not always possible, and we have to accept that, and we'll drill and mitigate in drilling through the gas. But there is a greater uncertainty in the soil and the behaviour of the soil anywhere that shallow gas is present. And a deep water survey varies a little bit. You've already got a 3D data volume, usually, that might well be as good as anything you can acquire with 2D data. And I've got a case study later on I'm going to show where a 2D survey was conducted along with a seabed survey, but actually they added no value or no further value than what 3D data shows. So the requirements won't always be the same. So the advantage we have here, we've got a 3D cube with a good regional understanding before we even design that survey. We need to know what we're planning with development installation. We might require a little bit of specific, localized, detailed data. How we do this is we use a risk register to define expected hazards. We then build a strategy based on those risks and define survey scope only after we've identified them. So we start with risk, define the data, and then the survey requirements. And that final point, this approach may show that a full offshore survey isn't worthwhile and might not add any value. So, marginal fields. And that's going to be complexity, environment, and that's going to lead to less legacy data, less certainty of conditions, a lot more unknowns at the planning stage. There are areas where we know a lot the world over. There are areas where it's completely open water, no one's been there before, and there's a lot more uncertainty in that. So we're going to have to do a little bit more and a bit more work to actually get the right result there. I think this talks a little bit more about soils, and we've been over soils a little bit, and rigs and foundation design and water depths and how they all change. And this is all built in prior to going out to survey and planning that survey. Those are the factors we need to consider before we design. It's in a well-known area. Lots of tidal wells around it. The geology is well known. So you can survey it one by one. That limits the costs. It's a little bit cheaper for everyone involved. Here we've got an open water site, one existing tie well, no infrastructure within the area, and so it's 11 kilometres by 7 kilometres as a survey area. It's bigger because there's uncertainty, and that uncertainty could mean that where we want to drill isn't possible. So we've got a lot more options. It also offers a lot more data for understanding development on the seafloor after we've drilled that exploration well. So the kind of point I want to make here is that there's, with an unknown and a marginal field, there's tendency potentially to use an approach that's worked well elsewhere, but it may not be the right approach for that particular site. And all we can do to mitigate that is use as much of the legacy data, as much background material, and as much knowledge of that area as we can to build the correct survey for that location. And some of the solutions to this, I've kind of covered the first point. A targeted integration of geophysical and geotechnical data. It might not be that there's availability of a geotechnical. There might be other methods, hybrid methods. We might be able to use some velocity information from the seismic to help with soils, CPTs, various options. Ideally, you'd have that borehole, but that might not always be possible. Early engagement between operators, survey contractors, and specialists. The more you talk beforehand, the better the survey will go, and the more likely it will to meet the criteria we need. But these marginal fields are not going to be low risk. Their diversity and water depths demand smarter, more targeted site surveys, not simply small, cheap ones. That won't always be possible, unfortunately. We're at the exploration stage here. So, open water. So the initial well location before we'd analysed data, and you can see from this, the well has been moved based on these contourites. So we've got steep slopes on the edge of those, and it was deemed that that wasn't favourable for drilling. So it was moved slightly. This is an example of where the 3D data has obviously been used very well prior to the survey, or the 2D high-res survey, because they have located this proposed well site survey, Geo. I don't want to move that unless I have to. That shouldn't be my decision or part of my remit. As long as there aren't hazards, and you have to then advise on the hazards and then have a discussion and see if anything can be done. Post-exploration drilling, we're looking at development surveys. So we're going to start to get some fixed installations in the field. There'll be some pipelines. And so we start collecting perhaps more targeted data. If we've done a bigger site survey to start with, we might well have enough data to cover some of these points. We can start our planning off that. There'll be corridors and things for pipelines will be required. And yeah, the shallow section, the top 100 meters, is sort of key for the foundations. So if we can get boreholes to 80 meters, 100 meters, that is really helpful for knowing the stability there. And then we start looking at the seabed to know the slopes. Is there any debris, any existing infrastructure that we need to mitigate when planning for pipelines and so forth? And that moves us into long-term seabed and asset integrity. And this is inspection work, so well-developed fields, and we're looking at pipeline inspections. And I mentioned earlier on this example here, where we have a spud pan that has been sat down on top of a pipeline. This was a field that they hadn't done any pipeline inspection work for a number of years. They had no detailed drawings of their assets. They really weren't sure what was down there. And obviously, that was not good news. So even once you've finished everything, pipelines are installed, your rig is sitting there quite happy, you still need to check things, and there's still a need for a bit of survey work. And these survey objectives and specifications evolve as the field matures and differ as we go along. Some of the sort of sensors and data types we acquire, just a brief rundown. If you're involved in site surveys, I'm sure you'll be very familiar with these. So we've got multi-beam for mapping the seabed in detail. Key considerations when planning a survey are the resolution of that multi-beam system versus the water depth. And you need the correct multi-beam for deep water, shallow water. Side scan sonar for picking point contacts and showing sediment boundaries, so forth. Again, you need to consider the frequency versus the line spacing you're trying to run. And obviously you get high and low frequency data. Low frequency data will cover a wider area, but won't quite show the same number of point contacts. So there's always a balance, and then a magnetometer for locating ferrous objects within the fields. So really useful for finding pipelines that are buried and so forth. Subseabed, we acquire high resolution 2D HR and UHR data. So typically to 2 seconds for the HR, but half a second for the UHR, and sometimes less. Electrical systems for sub-bond profiling. So those could be a pinger, a chirp. An Innomar has become very popular in recent years. And this is a really nice sort of comparison of 3D data. This is 3D data as acquired, so it's focusing on the deeper stuff. We sometimes see short offset reprocessed 3D cubes to provide a little more detail in the upper section, but this hasn't been. So you can see the difference between the 2D and the 3D in the upper section. A lot more detail, and then you get to a point around about here where the 2D has lost a bit of punch and the 3D comes into its own. And then a really nice example of the limitations of 2D versus 3D, faults. Much easier to map off 3D data than 2D data. And this is sort of taking the resolution thing a little bit further. This is 2D HR versus two different forms of UHR data. Bigger gun, bigger streamer, smaller gun, smaller streamer. And as you work through them, you go from low res to high res, but less penetration to more penetration. So it's always trying to work out the correct system for the environment you're working in and the objectives that you have. And that will always change. And the final point, and always done afterwards, the geotechnical data. Firstly, because we have to be certain of the conditions that we're going to drill our geotechnical data in. So we need to acquire that sub-bottom profile or that UHR to clear the point we want to drill. So often we'll do a little clearance report on those specific locations to say it's safe to take a geotechnical drill rig and drill there. The same is true with the CPT and Vibrocore, and we always have a look at what's going on the seabed. Is there a hazard that we might be hitting? Is there an asset that we might be near? We shouldn't be acquiring geotechnical data next to a pipeline, but it does happen from time to time. We'll also look at the slopes because the CPT might not operate on a steep slope. It might just topple over, and then it could give us a questionable result that doesn't really help us. So we build these into our model with our geophysical data. And here are several examples of how we've done this. Very traditional sort of well logs or borehole logs on top of the seismic. This was a very complex North Sea survey area. You can see by the line pattern down here. This is an example where about £2 million was wasted on a survey that didn't actually map all of the horizons, didn't show them particularly well, and they had a real issue setting the first casing. And so we went back and did a very tightly line spacing. And I think today that would have been a 3D UHR job because we'd be imaging those steep slopes even better in 3D. A lot of sort of color coding of reflectors versus the geotech is now very, very common, and we're laying a lot more sort of logs and resistivity and things over the top of our data these days because that's a real sort of client focus now. And so a final point on data acquisition. Data is not collected to look good, it's collected to reduce risk. Key point to start with. And a survey that costs a lot of money but doesn't answer that question is a missed opportunity and can be misleading. So we want to try and get the right data for the right area. And a few case studies that I've worked in here. This is in OML 86. It's about 10, 12 meters. And there was a crater. We didn't get any background material particularly. Legacy data here would have been brilliant because it would have allowed comparison and ties, and anytime you can get legacy data into a model before you start acquiring data, you'll end up with a stronger product because you've got an idea of what you're expecting. We could see gas escaping on most of the sensors, so we can see a little bit of shallow gas even on the sub-bottom profiler. You could see shallow gas on the sonar data. And across much of this area, there was just a shallow gas front that just hides the data. And you get little strips, little pockets where you can actually see something. And one of the dangers with this is if you just acquire data from, say, here to here, you're going to see nothing. You might think the equipment isn't working. I've seen that before where people have doubted their equipment because of shallow gas. So where building this into a model with a load of legacy data will help out is that you be expecting that from the outset. You might not doubt your acquisition. This is the data I talked about earlier. There had been an abandoned well again in this area. Limited background data was shared again. But once we acquired the 2D, we could see a plume that had come up from somewhere. We again could see that the location had been very well picked because it had avoided the shallow hazards. But with some drilling information, some previous 3D data, we would have built a much stronger model here than just having the 2D HR alone. And a final case study. In about 500 to 850 meters water depth, where a conventional site survey was carried out. So multi-beam, side-scan sonar, magnetometer, sub-bottom profiler, and 2D HR. The bathymetry data was acquired with a sensible multi-beam system, a Reson. That's a pretty good Deepwater multi-beam system. But it was gridded at 15 meter cell size. We've got a 3D cube with 12.5 meter bins. You get a more resolute sea surface from that than you did from the multi-beam. The sonar's positioning accuracy expected to be at best 30 meters. You could pick most of the things off the seabed map from the 3D cube, and it's more accurate. The sub-bottom profiler, 10 or 15 meters horizontal resolution and 20 to 30 meters horizontal accuracy. It didn't show any reflectors anyway, but it's not really a particularly accurate tool with those numbers for doing any work afterwards. So the message in this state for this site was using the 3D cube and having planned it that way would have been a lot better option. It's no less resolute, and it has much more regional context. So that's an example of where plans could have been different. So a few key lessons and best practices. First one, over-design, under-design of the site survey. This is an example I've shown a couple of times, but originally the plan was just to acquire these areas, and then we added in all of the regional tie lines. And the regional tie lines give a whole lot more context. Although not great, at least they give you an idea of how the data should look where the shallow gas isn't masking everything. So we need to know the risks and then design that makes sense in that area. Availability of equipment. We might not always be able to get the equipment we want when we want. We need to plan in advance. Geotechnical drill rigs are difficult to get hold of, particularly at busy times. So the more planning, the better. Balancing cost against risk reduction. The value of early contractor and specialist involvement, that goes back to the geotech, the line planning. We need to get people involved who know what they're doing to best plan that survey and have a good knowledge of local geology. And that will come from specialist involvement. Final slide. And just as a conclusion and a sort of summing up, I'm just going to talk about some of the emerging trends that we see in site investigation. The big one is the uncrewed survey systems. This is what everyone, it was Oceanology in London last week, and everyone was showing off their uncrewed systems on their stands. And so they're probably going to come in more and more. They're great for certain water depths, probably not going to be used along offshore, but for pipeline inspection work, near shore, brilliant tool. And just acting as a library for work.
So I'll quickly go on to introduce the panelists. They will say a few words, in addition to what Chris has just said, and then I will hand over to the chairman to now moderate for questions and answers so that we can wrap this up. So can we have the light on? I'll first of all introduce Mr. James Ukachukwu. He's the MD of BOCA. Am I correct? So, Mr. James Ukachukwu is a strategic leader with over 20 years of experience managing complex onshore and offshore projects. His background in geology, geophysics, and commercial law provides a unique blend of technical and commercial acumen. He is currently the chairman and managing director of BOCA Energy Services Limited, executive director for SciSpace, Geoscience Limited, and Deepwater Limited. So, thank you, James, for being here with us. So, with him is Reginald Ofebu. I know I've met him a couple of times. Reginald Ofebu is a senior oil and gas executive and technical leader with 35 plus years of experience across exploration, appraisal, field development, and asset optimization. He retired from Chevron in 2021 as manager to Deepwater at Science supervisor after a 24-year career spanning onshore, offshore, and deepwater assets. He currently serves as managing director, Energy and Natural Resources Consultancy Limited, executive director, operations, BOCA Energy Resources Limited, and chief technical officer, Deepwater Nigeria Limited. For multiple energy consulting and services companies, providing strategic and technical oversights on drilling programs, field development programs, seismic and geotechnical operations, and production optimization projects for both local and international operators, including recent support for Chevron Nigeria's Partner 2 drilling program and PPL and NPCL assets in OML 86 and OML 88. His strengths include field development planning and execution, capital project maturation, reserves growth through infill drilling and well intervention, and joint venture stakeholder engagement. Career highlights include leading the Agbami Deepwater infill campaign, 11 successful wells, and leading the subsurface team, over 50 horizontal infill wells, including Project Cheetah and major gas development projects during his tenure as Chevron. He holds an MSc in geology from the Colorado School of Mines and a BTech in applied geophysics from FUT Akure. So I'm sure the guys from Akure will be so excited here, and is a member of NAPE, NMGS, AAPG, SEG, and SPE. Thank you very much, Reginald, for coming. So James, please, you can come up and shed more light on what Chris has just said. After you, then Reginald could also do, and then we go into questions and answers.
Thank you. So, good afternoon. Am I audible? Okay, so it's important to understand, we can't overemphasize the need for these site surveys. It's important to have a clear look ahead of any activity you are planning to carry out within your facility offshore. Be it you are planning to use a vessel to go carry out a maintenance work, or you are planning to take a barge to go do walkover, rig walkover, major rig walkover, or any activity, bringing in a rig to drill a well, it's important you identify the potential risks that exist within that environment. Because you need to understand where you are going to, how you're going to carry out that activity in a way that is safe, that ensures the safety of lives, the equipment you are bringing in there, the environment, the community around, to ensure that this is done safely without having an incident. Because the last thing we want to do is encounter surprises when we're planning to, or when in the course of carrying out these activities. So when you are aware of the potential risks that exist, then you can classify this risk into high risk, mid risk, or low risk, depending on, as the case may then you can, if it's a high risk, if there's this high risk there, you can now say, okay, you plan alternative ways of carrying out the activity. For instance, you want to lay a pipe, but there are risks that will not allow, maybe that pose a risk to maybe that infrastructure. then you need to find another way to get to that particular point. If it's drilling, maybe there is a shallow gas that exists, then you now find, maybe you plan alternative well, way of drilling that well, to avoid that potential hazard, to avoid having an incident. So it doesn't really matter what activity we are planning to carry out, but it's important you plan it in a way that is not, you are not carrying it out blindly to avoid an incident. So when this is classified, if it's high risk, you avoid, plan alternative. If it's medium risk, then you can say, okay, yeah, I'm aware that this thing exists, but I can now plan control measures that will ensure, okay, I'm carrying this activity out in a way that is controlled. So that, yes, it exists, should there be issues, I already have control measures to mitigate against an incident. So, but if there are, maybe for instance, if the risks are low, then yes, we say, oh yes, we are aware that these risks exist, and we are carrying out our activity in a way, in such a manner that, we are aware of those risks. So we can't really overemphasize that. So we also, another thing I want to mention is what he highlighted on about pre-planning these activities to ensure that all stakeholders are involved. Because, yeah, we want to earn money, we want to make money as a company, as a business, but at the same time, we also want to add value to the company or the client as a stakeholder, So if we have this data, we will be able to save costs for the company in planning a tailored survey or activity that, save costs for the company. And also, if we have good lead time, we can actually, maybe we have, for some marginal fees, maybe we have people who are aware of companies that want to carry out activity. We can actually plan it in a way that, you can merge the activity in a way that your mobilization, you save cost on mobilization, and that's cost savings for the company. So yes, in as much as we want to earn money, you can, if you involve all the stakeholders and have all the people planning this activity or getting involved, it saves you cost, in that you have you save cost in mobilization, and also have a better way of tailoring your surveys to specific need of the company. So we want to add value for the company while we are earning money, just us earning money. So it's important to be aware of that. And summary, we cannot overemphasize the need, to be aware of, these hazards in order to save lives. The property, we have millions of dollar facilities out there, and the last thing you want is to have an incident. It doesn't just affect lives, it affects the environment, it affects community and the reputation of the company. So, yeah, it's important that we pay attention to these things. Thank you.
Thank you. Thank you very much, Mr. James. So I'll call on Mr. Reginald. But before you come, please, I want to recognize one or two of our fellows that walked in. I want to recognize Mr. Ajibola Oegbamiji, FNAPE. I want to also recognize Mr. Emmanuel Egbele, FNAPE, and also the Vice President of NAPE. I want to use this opportunity also to recognize Mrs. Adedoja Ojelabi. She's online. She's part of this session. And then for the ESCOs online, we have Mr. Adekunle Shofolobo. He is the EIC, Editor-in-Chief. And then Mr. Afolabi Fotumbi, who is also the UAPC Chairman. Thank you.
Thank you, Tony. So I'm just going to hit on a few points to build upon the brilliant presentation by Chris and the follow-through by James. So my summaries are just going to be about what the takeaways should be for us here. I'm bringing it down to the Nigerian context as much as possible. That is where the relevance is for most people in this room. And one thing that I have been able to put together are the gaps that I see within the Nigerian industry, and those gaps are opportunities that I think we could focus on here. There's the tendency to rely on though the legacy works. However, there's a flip side to it. There's a tendency to carry on with the legacy data, even though evidence might, suggest that some of those are outdated, as it were. That is where the tendency to pinch the pennies are coming. So whereas we want to recommend optimization, it's also important that we know that, particularly in the deltaic environment, where things happen rapidly, for some of us who have operated in the swamp, you know how often you need to desilt a location, how rapidly things change and all that. So you want to bear that in mind and recognize that though it helps to integrate the legacy data, has been said, you also need to be on top of the dynamics. Now, there is, again, a cultural thing, which the tendency to operate in silos, as it were. The subsurface team wants to operate as an independent entity of the surface, of the engineering team and all that. A lot of the problems we have, and I think you hit on the planning, stems from the fact that we culturally want to operate in silos. So coming up front and sitting together in one room and agreeing to the key objectives and bringing all the moving parts to the table to draw a plan is going to help in this optimization question we're talking about. I wouldn't overemphasize the fact that the surveys are not fit for all. You have to tailor your surveys, you have to tailor your studies to the peculiarities of the environment and the purpose. That's also a very important one. Logistic constraints, you talked about that. The vessels are always tough to find around, not because people cannot bring them in, but you bring them in, you're tying them to a contract, you are incurring costs. Again, there might be an opportunity for us if we could work together. That's one optimization thing I'm going to touch on here. If we find a way of either multi-client or multi-industry working together to pool resources to manage this expensive logistics aspects of the business, perhaps it could help all of us when we really want to focus on our own little space. So a strategic shift is required, therefore. Target surveys to answer your specific questions. Don't just shoot in the dark or carry my plan and run with it. Integrate all the data you have up front. The screening always works. There are a couple of examples that were shown here where the pre-screening actually helped to direct a better optimization of existing data and the better use of the resources. You don't want to go shoot 2D high res in an environment where you won't get the resolution. If you have a 3D cube where there's reasonable signal within, perhaps that might be used to do a better job than high res that is masked and you couldn't really see the information. It's long-term synergy and optimization that if you consider and plan a survey to look at the life cycle of a field rather than just the specific project that you have at hand. For example, you have in plan somewhere within the FDP that you would be installing some sensitive facilities like a gas processing plant somewhere along the line. You might as well, ab initio, have your plan to capture all those opportunities, mobilize once, get the job done, have the data filed so that you're saving the cost up front. There is a present value, conversation around that. So you want to be sure that your economics are worked such that you factor in a life cycle perspective to it, so that you can gain your optimization and help your decision better. High impact solutions, you guys have talked about that. Risk-based rather than capital. There's a tendency that we look at these expenses as, capital, just something that I have to spend to check the box. But if we look at it from the perspective of what do I stand to lose if I don't gain this information and an incident happens? If you run your economics and your sensitivities based on that, perhaps you would quickly see the reason why you want to invest some of that money upfront. Screen wide, zoom deep, optimize your cost. You may reuse data as available. I think I spoke about that already. Integrate all the opportunities you have. Make sure that as best as possible, you are acquiring the data, you are interpreting them, and you are also identifying the applications in one sweep, so that the experience of all the parties that are involved are gained at the same time, and that you are not losing any details from what the data acquisition crew has done while you're doing the processing and interpretation and the application to your specific solution. And that full range, again, also helps to optimize your cost. The tendency in some cases is you contract to a different company that does the acquisition, another company does the interpretation, another company does the final application to your specific solution, as it were. You want to save that as much as possible. Another great opportunity for optimization would be if we start thinking multi-client at this stage. Particularly, you have a situation where our fields, we now have a case where several fields are located in a block, for instance, and many more small players are coming together to work within the vicinity. Perhaps this is a time to start framing those opportunities. The regulators might actually help here as well, such that rather than me doing my own thing in my small cubicle, I might be encouraged to speak with him so that we optimize the economics and we plan and gain the most for the bulk, as it were. Early contractor engagement has been talked about already. The autonomous systems are things that where we have a hope of a future. I don't know how those ones are going to pan out, particularly as we start getting shallow and we start having a lot of disruptions to deal with. So the takeaway here basically is cheaper surveys, or the money we save from not spending that money, is not always a profit. If we look at it from the point of view, we reduce uncertainty, we align with development decisions, we integrate disciplines early, we design with our peculiar, the Nigerian environment, the fiscal environment, the statutory environment, communities and all that, and the fact that the logistics can be tight. We need to factor all that to the plan to be sure that we get the best message. To us generally, value is created not by how little we spend on surveys, but how effectively they prevent costly mistakes. And we've seen a couple of those recently, particularly with our new operators who are just learning the ropes, as it were. I think speaking to experiences, including ours and several others that are out there, and talking to us in good time, and rubbing minds to ensure we bring a solution that works for us in a timely basis is something that we would encourage. Thank you very much for listening to us.
Thank you, Mr. Reginald. So at this point, I'll hand over to the chairman to go ahead and moderate questions and all that, summarize and everything. Okay, you have your... All right, Mr. Chairman, sir, please.
Yes, thank you very much, Chris, for the very insightful presentation. Chris has taken us through what needs to be done and the usefulness of geophysical and geotechnical survey, all the way from exploration, locating where you place your rig for exploration drilling, to know your geohazard point so that you can avoid them. He took us through all those. He also showed a lot of case studies on the different terrains. Yeah, so, and also he also delved into the usefulness of the survey in your pipeline routing, knowing the nature of your seabed, your near surface information. So he delved into this, how useful they are in placing your offshore facilities during development. So you find out that from what he has presented, site survey is very relevant, very useful, and necessary right from your exploration phase up to your development phase when you place your facility. So anytime you want to drill a well, you know that you need to do a site survey to know where to place your rig and the best position for your well after locating the subsurface structure. So these are an area I think we the geoscientists need to really see as a niche, because it's relevant all through the life cycle of the field. So he also delved a lot into how you plan your survey, the relevant things you need to do, how to optimize your survey, how you use legacy data and integrate it to the current data, and the new technology which is in place now. That's the unmanned crew, so which is the new trend in the industry. So he's done extensive work in both acquisition and interpretation of geophysical and geotechnical data. So the only aspect, maybe as first question, which I would like to ask Chris is, do you need geotechnical and geophysical survey for the commissioning of your facility at the end of the life cycle of the survey? So, because you didn't show any maybe case study on that as well. So with this, I would like to kickstart the. I think I also have another question. So typically, Chris, how long does it take for a rig site survey to locate your rigs where you put your rig, especially your jackup? How long does that survey usually take? So I'll use that to kickstart the question and answer, then before we go to the audience. Thank you.
Yeah. Okay, before Chris, you go ahead. No, take the mic. So before Chris, you answer, just to tell everyone how it will run. So it will be moderated by the chairman and myself. For the questions, we'll take questions from the room first. We'll have the microphone go around. So anybody that has any question, you raise your hand, and then you ask the question. Any of the panelists, chairman, anybody that has any insight into the question can answer. Afterwards, we will then switch to the online platform to get more questions. Thank you.
Yeah, thank you for those questions, and they're good questions. From sort of planning a typical site survey, we will receive all the available legacy data. We'll have a preferred planning location. We'll likely produce some kind of desk study that will take a couple of weeks. We'll work on the permitting then, and several things have to go to the regulatory bodies wherever you're working in the world. So that is then pushed back with the areas in which we want to work, what equipment we're going to use, how large our survey area is, whether there's geotechnical operations, so forth. And that can take any amount of time from a few weeks to months. The actual acquiring of the survey data for a standard kind of 2x2 survey area is probably a week or two. We try and do a lot of single pass surveys these days where we're running all of the sensors at once in the North Sea. That causes you problems on occasion if your frequencies interfere and you end up with compromised data in one of the sensors. So it's not always possible. It takes clever setup, a decent sized vessel to keep the sensors a good way apart. But yeah, a typical site survey, couple of weeks, depending on the weather. And then typically 4 weeks to report, which is usually split into 2 weeks for the seismic processing, 2 weeks for the interpretation and reporting of that, and in that first 2 weeks we'll be interpreting the seabed sensors as well. On the decommissioning, and these are very popular in the North Sea, and I'm working on a couple currently. We're quite lucky in the North Sea, certainly in the North Sea, that sites don't change. The geology hasn't changed. There's no deposition has occurred in the 50, 60 years that these rigs have been installed. And so you only need a certain amount of data for a decommissioning survey, as long as you've got some legacy data. I'm working on a project at the moment where the rig went in 1977, and we're using a 1977 borehole to avoid the need for additional geotechnical acquisition, which would be very expensive, very tricky, right next to a rig. And everyone is trying to avoid that. And we're using that borehole with some newly acquired sub-bottom profiler data, and a couple of other boreholes that we're going to tie to within the area to mitigate the risks, to not require any further geotechnical acquisition, but we will acquire sub-bottom sonar and multi-beam. Because what you see a lot of with a decommissioning survey is debris, certainly from something that's been in from the 1970s, where things have fallen off the side of the rig and ended up in the water. They probably shouldn't now, but that has happened. And so we're looking at seabed debris and whether there's an obstruction that could impinge the jack-up operations there.
So now we take questions from the audience. We take as many as possible.
Okay. Thank you very much. That was, thank you, Chris. That was a very comprehensive presentation. I really do not have any question to ask. And I thank James and Reginald, my former colleagues, for bringing this together. I saw, this is very selfish question. I saw a slide that showed the Volans 1, the well. Is that a Namibian well? And the follow-up question is, that's a very disturbed seabed. We don't have, you said you are lucky in the North Sea. We probably are also lucky. We don't have that kind of but do you have any slide that also shows that sort of deepwater seabed in the Nigerian case, you know? But precisely what were you trying to tell us that's really very conflicted space, you know, and you showed quite a number of curves. I mean, those are channels, right? Okay, thank you.
So the Namibian example, and good knowledge for knowing that Volans was Namibia, those are contourites. So those are depressions that are formed specifically by bottom currents, and they have a really scattered appearance and occur at certain water depths at certain points on the slope. Not a particular hazard apart from the gradients that occur on the slopes of them, which are obviously not ideal for stability when drilling, which is why that particular well was moved. In terms of similar things that were in the presentation, there was the mapping that had been done of the seabed with the mud dipiers and fault scarps and various other things was from Nigerian waters and taken off 3D. And actually there was where I was showing the 2D survey in the 500 to 850 meters water depth, which wasn't really suitable. The mapping off that 3D of the seabed features was more accurate than the 2D survey and ended up being a bit more detailed as well. So that was a Nigerian example of that. And that was a very nicely reprocessed 3D cube, that one.
Mr. Tucker, yeah.
Good afternoon, everyone. My name is Alex Tucker. I'm the CEO of La Coastline Energy Base in Abuja. I want to thank Chris for this wonderful presentation, together with James and Reginald, as well as the chairman for the occasion. My own will be more of contribution and then just a little question. I happen to have been among few persons here that must have been deeply involved in this while in service. I inspected a geotechnical vessel in Lowestoft some time ago for a job in Nigeria, and a geophysical vessel in Aberdeen. It used to be part of an area I was very much interested in. And I want to warn us, for those in operations, cost saving for site survey is not actually cost saving, because when the problem comes, you discover that what you incur will be much more than that amount that would have been used in cost saving. I'm not marketing for BOCA. I'm trying to warn us based on personal experience. If I had my way, this topic would have been from land to swamp to deep water, because the challenges are also on the land operations. The experience on land was a situation where everything was done as expected, and yet, just at the stage of drilling just borehole, there was a supply water for the rig to drill. it was just gas and just fire everywhere. So in a situation like that, when you must have done all what you are expected to do, and yet you are encountering such things, what will be your suggestion to enable operation to still go on smoothly? Because it got to a stage that borehole drilling became a challenge, and then water trucks, what do you call them? Tankers have to be supplying water for drilling operation. You can imagine such level of frustration. So when you do everything you are supposed to do in terms of survey, and yet you get to experience some of these unusual happenings, what do you do? Also, there was a case of an operator that was trying to save costs in a shallow water location for a jackup. And the argument was much, the rush was much, and we decided to move that rig because operator claimed they understood the environment based on so many activities within the same location. At the end of the drilling, it went successfully, but for the jackup to move, it couldn't. It became a lot of argument. Somebody had to suggest that one of the legs should be amputated. It was going to be the first amputation of a leg of a jackup in Nigeria, so that the owners will take it and fabricate it again before it will come back. So I'm giving these examples. They are Nigerian examples when we try to save cost when it's not necessary. The cost of getting out that jackup was much more than the cost that would have gone into the survey. I don't want to take too much of our time. Those still operating, let's be careful with cost saving when it's not necessary, because the embarrassment and the cost you will finally incur will be much more than the cost for this job. Thank you very much.
Can I take this? Yeah, thank you, sir. That's a very, very insightful one. And yes, I do agree absolutely. It should actually start from land. As to your question, are we really sure we've done all we ought to have done? That's really the pushback I'm going to bring in here. And the emphasis should be that we integrate all the functions at the very get-go. Most of the problems, like the one you just touched, has got to do with the fact that certain functions are blind-sighted at the planning stage. What is the source of the gas? It's primarily not likely to be there. So something across the dynamics of that field brought the gas to the shallow levels, and it's not known. We've had situations where we mobilize to either dredge or whatever in locations where there are buried pipelines. There are no as-built drawings. There's nothing to show anybody that these pipelines were buried in there. In fact, there was about 4 or 5 years ago, there was a fatality in one of the operations where a facilities team broached an existing pipeline because they didn't know that that pipeline existed there. So we have all these kinds of things happening because, once again, the tendency is for us to always want to own that, shop. I am the asset manager, I'm the exploration manager, I'm the facilities manager, and the whatever else. I don't want to speak to the next person because I don't want him to steal my idea or for whatever other reasons. And so we need to deal with this situation. And before we engage on these operations, I think it's important to emphasize that the kind of risk assessments that we conduct should include all the functions that have anything to do with those operations or those assets. That's the only way we can catch situations like this. But be rest assured the tools are there. Be rest assured there is a function within that system that has an answer that could have picked it. We blindsight the right person most times. That's really the problem. Thank you.
Yeah. I think I would like to add to what he just said. These things, that you can't overemphasize the importance of carrying all stakeholders and planning, because during that planning phase, if all existing data is integrated and looked carefully, there will be signs. You will see some signs that will help you put control measures in place. Should this thing happen, you have a mitigation for it. But where you've not exhaustively looked at all available data, information, even as much as operational information around that area, sometimes we play down on information that regards to guys that carry out daily operations around the area. They must have seen some things that will give some signs. So if you have access to all that information, put them together, do an elaborate assessment and planning, there are things that will give you not the information you need to plan properly, to actually risk what you're about to carry out and know that, okay, this is actually a medium risk operation. Then I have to have that control measure in place. So that control measure is meant to, to be there so that when you need it, you can now pull it and mitigate an incident happening. So thank you for that.
Yeah, good afternoon. My name is Darlington. I work with Sea Finds Energy Limited. We're basically into marine services, marine support services. Brilliant presentation from you, Chris. I just want to comment, just a few questions, just a small question. On the area of just for learning purpose for the students amongst us here, I was expecting to see a clip of your, I give an example, your geotechnical SBP, because I saw something you did, there was a presentation on SBP, sub-bottom profiling, how it works, because you are displaying maps and results, which is brilliant, but students want to see how this works, a video clips, and also what kind of equipment, the hardware you deploy for such a solution. Like I know of one, HTEC 216X for the SBP. So if you have, you can just throw more light on that. Thank you.
So if I've got that correct, you'd like to know how the sub-bottom profiler is operated and how it works, essentially, and then the resolutions of these data sets and frequencies. Is that correct? Sorry? Yeah. So a sub-bottom profiler varies from a seismic solution, where seismic solution has compressed air, that is pumped into a chamber and then forced out, and you create a bubble, and that sends a wave that propagates. The sub-bottom profiler systems are electrical systems that operate in a similar way in looking for reflections, but it's an electrical pulse that's fired towards the seafloor, and then obviously it's measuring reflection time and intensity to various different layers. They have limited power sub-bottom profilers, so there's many different sub-bottom profilers, and they all offer something different. So some will penetrate a lot further than others, so the soils will also affect that penetration. So a standard kind of pinger in sandy soils will probably only penetrate 4 or 5 meters. So it might not be the correct solution because it's quite high frequency and is struggling to push through. You move up into boomers and sparkers, you've got a bigger electrical pulse, more nodes, and so you can, or more tips on a sparker, so you get a bit more power, a bit more punch, but they're all working off the same reflection idea and intensity. In terms of frequencies for sort of operating systems, your high frequency sub-bond profilers like an NMR are operating at 8 to 10 kilohertz. A pinger is about 4.5 kilohertz. And then boomers and sparkers, 500 to 2 kilohertz, 500 hertz to 2 kilohertz. So the lower the frequency, the more punch through soils you'll get, the better penetration, but that is offset against resolution of the layers that you can actually delineate. So if you're planning a pipeline route and you're looking for detail in the top 3 meters, potentially you've got some kind of problems, a layer that you're not certain of, you'd want something really high frequency. If it's for foundations for a rig and you're looking to get to 80, 90, 100 meters, then a lower frequency sparker, boomer, is a much better option. And you also sometimes find that your requirements stretch all the way across the board, and so you're looking for something that's high resolution and something that's low resolution, and you end up having to run 2 sub-bond profilers if that's the case. So yeah, it's geology and requirement specific. Does that answer you happy with that? Yep.
Thank you, Chris.
So, any other question? We need one more question.
One
from
more
the
question
audience,
here.
if we have. Okay.
Hello, good afternoon. My name is Kelvin. I work with SLB. My question is for Reginald. I wanted to ask, with the high cost of deepwater site surveys, during Chris's presentation, magnificent presentation by the way, I heard when you mentioned it would be beneficial for the region to embark on multi-client surveys. Is there a case for this? And if there is, in terms of the barrier, commercial or competitive, which in your opinion is preventing the country from moving in that direction?
Thank you. That's a very good question. So for me, I think the biggest barrier is the culture. And when I mean culture, now I mean that as companies, independent companies, traditionally, we had carried the subject of competition into even hoarding the data we have. So the tendency is, I think I'm losing, competitiveness by letting you know what's happening in my area. So I think that culture is something that, that inertia is something that we need to really intervene with, as it were now. And then make a genuine commercial case. There is a commercial case for it. We can work the, economics involved. We can demonstrate how our values, as it were, converge, particularly now. And I would, emphasize that. It used to be that we could hold, licenses, forever. But with the current constraint and the fine-tuning of the lease, particularly the exploratory lease and even the marginal lease agreements we're going into now, where you have a set time, a set period to execute certain minimum work obligations. There's a lot more ramification for people to come around and say, okay, if we must drill a well within this 2 or 3 years, we need to sit together and do something together. And then it's easy for us to work the economics then, spread the cost, and gain the synergy involved. Again, I'll keep emphasizing, we could wish all these things, but if there's no stringent control from the regulators up there, who also help to show us why we should do these things and why we should start considering doing things in a different way, it's never going to happen. So I think the commercial is the least, but people have got to sit down and agree to look at the numbers together and come up with where the advantages are. It's going to be obvious.
Yeah, before we go online, just to add to what Reggie is saying on the multi-client option. I think considering multi-client option now, NUPRC now offer exploration license for those who want to do multi-clients across the basin, the Niger Delta basin, even in the frontier. So if it is commercially viable, you can seek that kind of license, that PPL, not PPL license, exploration license to acquire multi-client data. If it's commercially viable for you, then you sign an agreement for what's it called, revenue sharing with NUPRC, which the seismic guy, the regular seismic guy, are already doing that. So I think about 2 companies already have exploration license to acquire seismic across the basin, which does not affect the PPL license that are given to the operators. So you acquire this data, yeah, you make it available, they come, lease it, buy it when they need it. So the business case is good for you. I think NUPRC will offer that license. Thank you.
Thank you. Thank you so much for the responses. Excellent questions. Unfortunately, this is we are going to end it here. We'll now move to the online, like was mentioned. So you still have opportunity. The presenters are here. You can ask afterwards. So I'll go straight now to the online. Unfortunately, online as well, we can only take 1 question because we are running behind time. So the question here is from an anonymous contributor. He's asking, or she, what do you typically consider technically when designing a survey? Anybody can say. What do you typically consider technically when designing a survey?
When designing a survey, the first consideration is what type of installation is going to go on that location, be it a jack-up, a semi-sub. The first thing to consider is what are we going to use within that area. Next key consideration is the water depth. The water depth defines your line spacing. In very shallow water, if you want to acquire multi-beam data, you need to acquire a lot of very closely spaced lines. It might be that you think single beam data will work and is satisfactory, and often in very shallow water it's probably as good an option because you'd end up acquiring an awful lot of multi-beam data to cover a large area if you're in 5 meters of water. You then look at the potential risks. What are we expecting to find? This is all based off your legacy data and what you already know about the area. So you look at the risks. So once you've considered what you're installing, the water depths and the potential risks, you come up with a sensibly sized survey area. It'll be larger if it's semi-sub, deeper water with an anchor radius that could be 1 kilometre or 2. It'll be smaller if it's a jack-up. And you also consider tie wells as well. So are there any wells within the area we can run tie lines to build up a better picture of conditions as well? And potentially existing survey data or boreholes, we might want to tie into those as well, so there could be additional tie lines there.
Yeah, thank you very much, Chairman. Thank you very much, Chris. Thank you very much, James and Reginald. So at this point, we will quickly, take the sponsors' remarks, after which the president will be called on to present a gift to our sponsors, and then publicity will give announcement, and we'll celebrate our fellow who turned 80, and then we'll do lunch. So please, sponsors, please, your remark. Go ahead.
Good day, distinguished guests, members of the leadership of Nigerian Association of Petroleum Explorationists, esteemed colleagues, industry partners, and ladies and gentlemen. On behalf of BOCA Energy Resources and our alliance, SciSpace Geosciences Limited and Peak Processing UK, I would like to sincerely thank the Nigerian Association of Petroleum Explorationists for this opportunity to partner and support this prestigious gathering. It is truly an honor for us to be part of this community that continues to shape the future of the petroleum and energy industry in Nigeria. NAPE has consistently served as a vital platform for knowledge sharing, professional development, and collaboration among geoscientists and industry stakeholders. The association's commitment to advancing exploration and fostering innovation within the energy sector is commendable, and we are proud to support such an impactful organization. And I would like to also mention that in that view, we are also going to be sponsoring the August technical session through our sister company, SciSpace Geosciences Limited, and our chairman is here. I don't know if he wants to, yeah, who has already benevolently said. And in the coming days and months, we want to be actively, we will be more visible in that collaboration with NAPE to see how we can, support and also work with NAPE ways to send people, train them, bring them back to add value and bring back knowledge to this, to foster development and, in our sector. So at this point, I would like to introduce us to the Alliance, BOCA Energy Resources, SciSpace Geosciences Limited, and Peak Processing, a dynamic and solution-driven alliance committed to delivering value across the oil and gas value chain. Our focus is on providing reliable, innovative, and efficient services that support exploration, production, and operational excellence in the energy industry. As an alliance, we strongly believe in collaboration and in supporting platforms that promote technical excellence and industry growth. This is why BOCA Energy and her alliance has committed to contributing to the continued success of NAPE and its initiatives. We look forward to strengthening this partnership and playing a part in advancing the goals of the association and the broader energy sector. Once again, we thank NAPE for this opportunity and for the remarkable work the association continues to do for our industry. We thank you, and I wish you all a very productive and rewarding time for the rest of the event. Thank you.
Very much, BOCA. Please, another round of applause for BOCA. They promised to sponsor a technical meeting for August. Please, let's keep clapping for BOCA. Their sister company is going to sponsor that. That is SciSpace. Thank you very much, sir. So at this point, I'll call on the president to come and present our gift to the speaker and the panelists. Secretariat. Okay, all right.
Thank you very much. Before I present the gift, thank you for picking August as another month that your company will sponsor. Thank you very much. And also the fact that you have promised to partner with NAPE, you know, especially in the area of knowledge sharing. And I'm so glad that a company is committed to doing that at this time when we are trying to put together NAPE Petroleum Academy. And we are working towards that. There's a committee putting that, you know, the framework together. So you are one of those who will be part of that program, and I will let the committee know, because we'll kick off that very soon. Once the committee has concluded, we'll have a town hall meeting where all industry players will be called, and it's going to mirror the Shell intensive training program of those days. So you can see that the area of seismic, you are committed to adding value in that aspect. So we've noted that. Thank you very much. So thank you, everyone. So, okay. Please, can you hold it and drop it? All right, our chairman, please, I step forward. Thank you for coming up to chair this event.
Thank you very much. Thank you for the patience, and thank you for your questions, please. The next thing is announcement by Public Secretary. Public Secretary, please go ahead and make this announcement so that...
Okay, thank you so much. I hope we've all enjoyed our time so far. Please, the slide up for me, please. Tunde. Tunde, please. Can you go to the...
Tunde, can you put it on presentation mode, please? Okay.
Okay, so I'll roll through our upcoming activities, ongoing activities, and all. So we start with what is fresh on the block, and that is our mentoring cycle from the Office of the Vice President. It has commenced. We are going to have the deadline for this. It's actually targeting me to early career to mid-career professionals. So the deadline for this is 20th of April. For further inquiries, it's as displayed there. Further information will be sent via email. We've already started via our social media handles. Yeah, so that's for mentoring circle from the Vice President's office. Take advantage of it. Our technical business meeting continue. This is the second one we've had for this year. The third one is we have for other chapters as well. But just to mention before that, our April technical meeting for Lagos is going to be April 15th. Stay tuned for more details on that. So that's for Lagos. Then for chapters, we have all of these ones as listed here. I'm sure you've been following us on our social media platforms, our emails on this information. So Warri is coming up next, March 23rd. Then that will be followed by Abuja. Then North America will be March 28th. Afterwards, we have the Benin chapter. The flyers have the details as to the timing and all that. Further inquiries as well listed there, Lawrence. Okay, next slide. Our big flagship event for the year. We've seen this before. We promised you that we'll supply you more details. We are here now with more details for that. Okay, so remember, the theme for this year's conference is unlocking more barrels, driving reserves growth through exploration, local capabilities, and adaptive technology. The very first thing is to put this theme in your head so you know what am I going to get from this conference. All right, so that will even propel you as to if you want to go further into submitting paper, coming for presentations. This theme, you should start thinking through it, put it in your brain, and let it start inspiring you on what to do. Sponsorship, as usual, exists for our conference, so take advantage of it. We have, go to the next slide, please. We have, I'll go into that, the different sub-teams where you can sponsor into. But we have fresh again on our blog, call for abstracts. You'll get more details of that. Just to let you know as well that for abstracts, the deadline for submission, again, you will see it in the flyer, ends 30th of June. That will be the deadline for submission of your abstract. Other details is as listed there. You will see it as we roll them through. Next slide, please. Now, this is where I was talking about. So you have all of those for people for sponsors. There are different events as usual that you can, sponsor. So different categories, golf, and management session, different sessions that you can indeed participate via sponsorship. Then registration is open. Details will come in later. But just one key thing I want to mention is that our early bird registration, which is where you save your money, will end on the 1st of September. So target that date and try to register within now and then, because afterwards the prices will jump. We have different categories for different registration, different registration buckets. Next slide, please. This is coming from the young professionals. They have their technical meeting coming up as stated there. So the topic is preparing for postgraduate studies abroad. I think this is very good if you plan to further your education. So the timing and all of that is the 21st of March. Flyers will go out so you get more details on how to register. Next slide, please. They also have another one on health series. So this is really for fitness and all. Thriving beyond stress, practical strategies for mental wellness. That's coming up 28th of March. So look out for more details on this. Next slide, please. Fundraising drive. This is ongoing and we're still on it. Please, 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 we are seeking your support to raise funds for the NAPE Permanent Secretariat. Join us, collaborate with us, so that we all have a befitting NAPE Secretariat that we will be proud of for many years to come. Next slide, please. So the payment details are all there. We'll keep sending out emails. NAPE dues, we cannot overemphasize this. Right, we are going to delist you by 31st of March. So please, the payment details as listed there. Continue. We've been seeing. Thanks for all those who have responded. We hope you will continue and help us in this drive as well. Next slide, please. Okay, that's it. Thank you so much. I'll give it now to Vice President PE to round up.
Thank you very much, PS. Because of time, the next thing is to celebrate our fellow who is above 80, So the plan is, or what we are trying to do here is, for any of the fellow who is 80 and above, whether they are 2, 3, or 4 in a month, we will just sing happy birthday to them and, project their a collage on the screen. So Tunde, please do this while I'm talking. Can you project? And then we can always sing a happy birthday to Mr. Daniel Ndefo as he enters the 80th floor. So can we go ahead? Happy birthday to him. He's showing now. That is Mr. Daniel Ndefo. Happy birthday to him. Happy birthday to him. Happy birthday to Daniel. Happy birthday to him. Thank you very much. So, the next thing is our lunch, or I'll give my vote and then we go for lunch. I want to thank us. I can't thank us enough. NAPE is a one big family. I want to thank the sponsors of this program, BOCA. They've also said they're going to sponsor the August part. That's their sister company. I want to thank them and thank them and thank them. It's not easy. We know what it takes, especially paying and then, bringing out somebody to come and present and all that. So I want to thank them. I want to thank our fellows that are here. I want to thank members that came around. I want to thank the students. It's not easy. You learn so much from associating yourself with what happens to your professional association. I want to thank everybody, and see you 15th of April 2026 when we will have another presentation. So on this note, lunch is served. The fellows and the sponsors and our invited guests, please, you move to the left of my hand. And then the rest, we have a serving point. I think we have a serving point there, and then one at the extreme. Thank you very much.